So, hello everybody. Welcome back to the final talk in this, the final session in the track, in the general track in today's PyData Global. So, this is the last one for this track today. We are joined by Chris Laffra. I hope I pronounced it correctly. And
Correct.
he
Yes.
is going to be presenting PyScript, writing a Python application in the browser. So without any further ado, I will hand over to Chris, and I'm going to put some resources and links in the chat. So if you want to follow along, just look at the chat. We will have the Q&A at the end. And Chris, I think I'll leave it over to you. So
Thank you so much, Kevin. Everybody, welcome. My name is Chris Laffra. I'll be talking to you about, or we're going to be learning about, how to write a Python application in the browser using PyScript and a library called LTK. Before we get started, I can see that in the audience, we already have quite a few people, and one of them is Fabio Pleacher. Depending on which country you come from, the pronunciation will be different. Pleacher in American. And he is the inventor of PyScript. So I'm honored that he is actually in the audience. So if you have any questions that I may stumble upon, then I'm certain that he will give a really good answer in the chat. So thank you, Fabio, for attending. So with that, let's get started. So this is about PyScript, writing a Python application in the browser. You may have seen some presentations already with demos. This one will be a little bit different because we're going to write a real application. So you're going to be looking at basically what is PyScript, how do you write an application in PyScript, what are some of the things you can do, and we're going to get practical experience. So you can follow along. If you want to follow along, it's good if you read the instructions in the original presentation description at pre-telx. And that is in the Q&A. So if you, or in the chat, if you go to the chat, there should be a link there. So basically, we'll do a VS Code plus the Python extension plus live preview to look at the web app that we're going to build in PyScript. And using VS Code is probably the most efficient way of doing this. I'll show you that in the middle of this whole event. Okay, so what we're going to do is talk about why we have PyScript. So what problems does it actually solve? It's very important to think about that. Also, how can you actually write a PyScript application and how do you run it and deploy it? It's a little bit different from a traditional standard Python application. But in the end, it just looks like a web app. And you will see this once we get to the description there. And then we're going to spend most of our time, hopefully, writing an application. Because I believe that just watching a YouTube video on somebody writing code is, it's informational. You learn something from it, but you learn the most from actually doing. So I highly recommend you try and follow along. Install VS Code if you haven't done that. Most people already have it installed. And you have the Python extension probably also installed. But install the extension for the live preview, and then you can follow along very easily if you clone the repo for the to-do app that we're going to write. Now, after we're done, we're going to look at a little bit more details, like things like performance and how does it actually work? How do you do things like styling of your Python application in the browser? So why PyScript? JavaScript development, this essentially nothing wrong with JavaScript. JavaScript is a great environment. You may think it's like a weird language. It has some strange semantics. But for the problem it's trying to solve, it's actually a perfect language. And the support you get in the browser for writing JavaScript applications is nothing you can probably replicate very easily. So rather than think like JavaScript is a horrible language, we should think about like how can we leverage the existing JavaScript ecosystem. Now it has a steep learning curve because there's many ways you can solve a particular problem in JavaScript. And yeah, there's certain religions on how you do web applications, the different frameworks and libraries that you have to use. So it can get like quite complex. And if you're a Python expert, which most people here in the audience are, you have Python background, you're a data scientist or analyst, or even a a Python backend programmer, it's a big investment to learn JavaScript. So what we want to do is find a solution for writing web applications that you deliver through the browser without having to learn JavaScript. So that is one of the things. Another thing is Python is an extremely popular language. There's more and more people adopting Python. And of course, the whole AI success, or the popularity of AI, has led to even more adoption of Python. Python is really the operating system for AI. And that has shown in, basically, if you look at any survey that tries to establish like popularity programming languages, this one is on LinkedIn job postings that mention the programming language, and Python is now surmounting all of the other ones in this year. So Python is popular, yes. There's many batteries. There's so many libraries to install, right? Or to use. SciPy, PyKit, Pandas, Data Table. All of these things are easy to install. And we say like Python comes with batteries. But in practice, it's not so easy, right? If you have to distribute an application, people have to install all these packages and the right versions, because maybe you don't support a certain version. So packaging really becomes a challenge, especially if you think about like how many packages there are. There are like 500,000 projects on PyPy. So this is like humongous, like so many. The amount of downloads that are happening from there shows how much effort we have to spend in figuring out what to download to install before we can actually run our Python code. So Python installation, we just summarize it. It's a pain, it's hard. And when there's a problem, there's a solution. And the solution, of course, is a better packaging solution. So if you don't like pip install, you use UV. If you don't like UV, you use Conda. And all of these installation tools have different trade-offs that they try to address. And this makes it even more complex, right? So there's not one way to install all of these complex packages. There's multiple ways. And there's like fights that we have with each other on how do you install Python. So JavaScript is hard. Python is much better, very popular. So how can we deploy applications without pain? So this is another discussion. This is just on on Blue Sky. And this is about like, there's a smiley face in there. The home of Python community is wherever people fight over Python packaging. But that's a reality. It's like, it's a big problem for us. So wouldn't it be awesome if you can just bundle up your application and then people can just install it very quickly, just clicking on a link and not having to do any installation? So all these things together provide the benefits of PyScript. So what you can do with PyScript is on your development machine in an editor, change your Python files, give them to a server, add some HTML and CSS, and then serve this up into a browser, at which point it will run the Python files in a standard Python VM. So the same VM that you use that runs locally, that can either be PyData, which is a fully compatible CPython VM, or a very small MicroPython VM, which is around 240K and 120K compressed. So that downloads very fast. It doesn't have the whole language implemented, and especially all these batteries. It's very small batteries, maybe. And so that's a trade-off there. You want to deploy very quickly. You want to start up things fast. Whereas with PyData, CPython VM, you can run things like Pandas, the whole NumPy stack, things like that. So much more compatible Python VM. But with those two, you can run the Python code that you edited in your development machine, you can serve it up in your server and then run it in any browser without any changes. So the Python is not compiled into WebAssembly. This is what a lot of people think, that, oh yeah, it compiles Python into WebAssembly. No, the actual VM is implemented, is compiled into WebAssembly. And the two projects doing that is called PyData, and the other project called MicroPython. So we will look at examples where we see the trade-offs and the benefits from either of these two VMs. But in the end, you can write Python code that runs on both. So first, some examples. What is PyScript actually, right? So we're going to look at a couple different examples that showcase some of the advantages of using Python in the browser. So the first one will focus on animation, and it will show that it's just a static HTML file. The second one, WebGL, will show that you can import any existing JavaScript library the same way that you would do in a normal web app with JavaScript. You can then access that, it gets exposed to your Python runtime. And there's a very clean access layer that PyScript takes care of that. So that allows you from Python to call out to any JavaScript APIs, including WebGL, but anything else. The third one is an example where we import packages from PyPy. So this is like the batteries, the Python batteries. And this particular one is Folium, which is a package that is a Python package designed for Jupyter notebooks that uses Leaflet.js, another JavaScript library, to render maps. And in particular, this one shows the United States. And then the third one, or the final one, the fourth one, shows the two MicroPython and PyData VMs that I mentioned. So we use to start up the application with MicroPython. It goes really fast, it will show that. And then in the background, we start a worker that then imports pandas and matplotlib. And that takes a little longer. We'll show like how long it takes, get a feeling for that. So what do they look like? So first one is the Christmas card. So when you run it, it looks like this. So there's animation there. And there are like, Christmas balls here in the tree that are blinking. So this blinking is done in Python. The card itself is done in JavaScript, so that's an animation. And the two are combined in this experience. So how does this work? You can see that this is built on PyScript.com. So it's developed on a hosted development environment for PyScript. And you can see the code. So let's click on that. And this takes me to the source code for that particular app that I was just running. And here we see that it's just one single index.html file. So if I go to the top here, this one says like, oh, there's a title, Merry Xmas, and then there's some CSS. There's some HTML here. And then at the bottom, we see we import particle.js. We create basically these bulbs that blink here. And then finally at the bottom, you can see there's a Python script that we import. So we see a script tag here. It says type is mpy, so that means MicroPython. And it says config is in PyScript.toml, but I'm not importing that. I don't have it. So this is just a template line that I copied from somewhere. But you can see here is like we import Python, LTK from Python, random, and then we add the ornaments basically in different locations. And there's an animation here. So this is Python code that handles these little bulbs here. So if I move the mouse, you can see the snowflakes are falling around the mouse. So this is done in JavaScript. So this is a nice combination of writing some Python code and some JavaScript. And it all gets really nice, clean, as you can see here. This is the JavaScript that creates all the particles. So that's using the snowballs basically that are dropping here. So let's make a change here so you can get a feeling. So it says Merry Christmas. So let's make that Xmas. And I save. And this is how this environment works. So you save your files, they get saved on the server. And then when I say run, it reloads this application by loading it from the server. And now you see it says Xmas. If I go back to my original one here, which is the hosted version, and I do refresh, it should also say Xmas. So Merry Christmas. So that's how this particular app is written. It's one index HTML file. Now this gets a little bit wieldy if your application gets a bit bigger, right? So you want to have separate files, but in essence, it could be a static file that gets just served up from a web server. And the web server here is hosted by PyScript.com, but it also works on GitHub pages or your own personal website. This is another example that I mentioned. This is doing a little bit more interesting JavaScript. So this is using WebGL, and there's a nice abstraction layer for that written in JavaScript called 3.js. And allows you to do like these shapes and then do all kinds of animation with them. So there's not so much a lot of Python running, but we're actually using the JavaScript API. So I mentioned earlier from Python, you can call out to any JavaScript APIs, including in this case 3.js. So we say from JS, from JavaScript, import 3. And then from here on, we actually do the same thing you would do in JavaScript. And you can say like render as set size, shadow map enabled, type is, and so on. So it's like we're writing JavaScript, but we're writing it in Python. You have functions here like def on mouse move. So you can see when the mouse moves, we run this function. So that is like changing the direction of like where we're looking at. So the camera aspect is also changed there. So there's some advantages like the familiarity that we have with using Python APIs like math random and so on. So we can use our the knowledge that we have, the skills that we've developed over the many years in Python, but we can call out to any JavaScript layers. You can see that the constructor is a little bit different in this case, so I just wanted to point that out. So in Python, we can't really directly call this. In JavaScript, you would say new and then space and then the name of this thing. So this is basically the way that you call out to the new operator in JavaScript. But other than that, it's all like you're writing identical JavaScript. The third example that I mentioned is using, rather than using a JavaScript layer, we want to use a Python package. So this needs to be installed from PyPy because it doesn't come automatically with PyScript or my application. So this gets installed when the application is starting. So when the web page comes up, WebAssembly launches, and the Python VM starts on top of that. It reads this PyScript.toml file, and you can see it has a list here of packages that it needs to install. So it takes a look, says Folium, do I have that? No, okay, I'll go to PyPy, download it, install it, and it unzips the distribution for Folium, writes it out to the virtual file system for the Python VM in WebAssembly. And then it does the same thing for pandas, and then my application gets launched. So in the index.html, we can see that there's going to be a script tag here. Yeah, here it is. And it imports, or actually it tells PyScript to start the Python VM, the pyodite in this case. Like earlier I had mpy, but this is actually py. And I say like load main.py. So it runs main.py. Again, it doesn't compile it to WebAssembly, it just runs the original Python code. And in this case, this one imports pandas, it opens Folium, you can see here, and it creates a chloropath. And then finally at the end, this is in Jupyter Notebooks, this would be rendered as the result of running a cell. In PyScript, you can call display and take that thing and display it, display the M, whatever the result is, that's the map. And then you can identify a target. So in my index.html, I have a target. So in here, there should be a div that is called, what was called map? What do we call it? Folium. Okay. So there must be a folium here. Folium. Yep. So there it is. So here at the bottom, I have an empty div that is the recipient of that HTML that gets generated by the Folium package when it wants to render this map. And the nice thing, this is an interactive map, so I can zoom in, zoom out, pan and whatever. I can press this button here. So this is an example of where we use third-party Python packages and run them in the web app. So this view here is a preview. It's a web app, so I can open this URL in the browser as well, or I can send the URL to somebody else if this was a hosted app. In this case, it is. You can see examples, PyScriptApp.com. If you send this link to somebody in an email, for instance, or in a chat, and they click on the link, they get the same entrance here. So you see PyFolium, that logo doesn't look so good. So can we change that, right? So in the assets, we have CSS. So the CSS here controls what all these things look like. So the logo here, font size 28. I have no idea. This is just, I'm making this up. I'm trying to see if I can make some changes. So let's make some changes. Oh, I cannot. It says it's read only, so I have to clone the project. Okay, I will not do this for this one, but you can very easily clone this project, click on this, and try things out and change some of the CSS for this particular application. We will do this for the to-do app that we're going to write, and you get the same idea. So another example is my personal homepage. So I developed this homepage. It's written in PyScript. It's actually using a library called LTK. So you can see that at the bottom, here's a link. And if I refresh this, you can see it comes up. When it comes up, it actually starts a Python VM, in this case, MicroPython. It then loads main.py, which is what I called it. And main.py starts populating this content here. If you want to see what that is, you can always do view page source. And here you can see that this is the HTML that is generated when I'm actually in the way now, I can see. So let me move myself over a little bit. So let me make the font a little bit bigger so you can more easily read it. So you can see there's some HTML standard stuff, script here. But the more interesting part is where we load main.py. So if I click on main.py, we can see the file. So you can see Chris Laffra on main.py. So that's the same file that gets downloaded by the Python VM when it gets told to actually run this file. So here you can see that I make all these entries here. So you can see this is a URL and this is a link, a URL to a picture. This is a link. This is a URL to a picture. So that comes back when you, when it runs this. Each one of these is one of those widgets that I have here. I call them item. The item is a class that I introduced. I wrote that. And it's a subclass of widget, and I do something specific to it. So I make it a link with a vertical box with a text, an image, and a text. So if you go back to that, you can see there's a text here, 2016, an image, and another text. So this, the three widgets together is a item. And this is how I wrote it in this case, in Python. So this whole page, this whole homepage, let me refresh it again. You can see there's animation in there. There's dynamic items that are generated. Make it a little bit smaller again, and then re-render. Now this is not a very complex application. The interaction is minimal to hovering over things, but it's nice that you could actually write something like this in Python. So then I showed that there was a link here at the bottom. It says like built with LTK. So what is LTK? So LTK is a layer of abstraction. So these are Python classes that were written to make it easier to deal with the complexities of JavaScript. So this is like Qt if you write a command line application or a native application on Linux or Windows. This is a similar library for writing web applications. Now, writing web applications, it's not that hard because there's a lot of things in the browser already. So there are already buttons. There are already, so if we look at inputs here, so all these widgets that you see there are native widgets. They're like JavaScript, HTML elements that you would normally use to write your web application with. So what we try to do in LTK is just a very thin layer on those abstractions. Now there's a helper library called jQuery that makes it easier to construct things in the browser. So we're not using much of jQuery, but we use the benefit of jQuery is to find things in the browser, to construct new things, and basically apply logic to multiple things at the same time. That is really the strength of jQuery. It's an old library. It's not modern, so people might disdain, but for this particular purpose, it's like ideal. So the examples that you see here is that these lines here, like .html, .css, are jQuery APIs. So a widget can do whatever a jQuery object can do. That's in essence. So you could call things like .css, .add class. You can do remove, append, append to. So all the things you would normally do in jQuery. And you will see later on what the benefit is there, how quickly you can build your applications that way. Now you can make changes. You can do event handling. So if I change this, you can see I got events here, and they're done with on-call. So this is another jQuery example where you can set an event handler. So like here, if the color picker changes, so if the event is triggered for change, then call this function. So change is a little bit defined up here. And so if I go to the color picker, this one here, then basically changes. And you can see when I do that, it says change color to this number. So we use declarative UIs. You can see the UI is very declarative. It's sort of, you can see the shape. So this particular part here is a vertical box with inside there's a text. So to choose the runtime. So here you can see this is really a vertical box with two elements inside. I can also control shift over elements in LTK, and then it will tell me what these elements are. So if I go down, I can see span, and a little bit higher, you can see the whole container. So that's a very useful tool for inspecting what is happening inside your application. You can see on the top all the different things you can do with LTK in this case. So you can do styling, but we're not going to go too much in detail, but this is an example. This whole thing is written as a PyScript application to showcase some functionality that you can do with this library. And this shows you the power of things that you can do. So you can draw into canvases, you can use SVG with event handling, you can make forms. So you could like order some pizzas and then say place order. You can play games, so you can do event handling and changes. So this shows like sort of the flexibility and the power of PyScript that allows you to write web applications, but then in a very familiar Python APIs. So you can do things like drag and drop. So this is using draggable. So all you need to do to make something draggable is called draggable. And this is a jQuery function again that is offered up by LTK. You can do things like tables. So basically any data-driven application that needs a UI to navigate through the elements or to show you or filter things, that's all possible. LTK also has a model view controller support built in. So we call that reactive LTK. So what that means is that you can write an LTK model. So in this case, we call it a product, and a product has a name, a price, account, a warranty, and so on. And then when I create my UI elements, I can just refer to that field in the product. So in this case, I say, this one is bound to the product.name, which is in this case a wrench, a default one. And the same for price, same for count, and same for warranty, and so on. So when I make these changes, and I make a couple updates, these are automatically saved in the state of that product. So the product is behind the scenes, it's updated. So these now have new values. And there's a callback on the model if you want to get notified. So in this case, it's called changed. And then I update the summary. So rather than add things to the UI, I say like the value of summary, which was an empty string, now becomes this new Python string. And because there's a field at the bottom here, right here, LTK text, it's connected to that summary field. So that's why it updates when we make a change. So if I do this, and then one day, and then change this, every time you can see it, it updates this particular model. So that's one way of making your application a little bit more stateful and not worry about events too much. Like event handling is a hard thing in UI development. And this is why React is such a popular library in JavaScript, because it takes away a lot of the having to think about events and passing data around. So it tries to make all these connections much more declarative. Okay, so that's LTK. The slides that we're looking at, so these slides here, let me go back here and show you different slides. Like every time we go back and forth, this is actually written in Python. So the whole slideshow is written as a Python application. So if you go to github.com laffra-slides.git, you can clone this app and make your own slideshow. And the way it works is you run convert PDF. It will ask you what PDF to download, and that's a URL to a Google Slides deck. So if you make Google Slides normally, you just point the URL to this tool. It uses PyMu PDF. So that's a PDF library in Python to extract all the pages, and each page becomes an image, and that is then rendered by main.py. So main.py is another PyScript application. You can see it's pretty standard. It has an image, a label. So these are like go left, go right. So if I go here and I move around, you can see left and right. And let's see what else is there. Then it handles the keys. So F is full screen, backspace. So I can also move back and forth with arrows, with letters, by pressing numbers. And this whole thing is like, if I go down, it's like 80 lines of Python. And there's no JavaScript. There's barely any HTML. Like the HTML is a very small file if we look at that. So this is all the HTML there is. It actually says loading, and it loads main.py. So this is in case that you're running on a slow network. When it has to come up, it says loading, and then once the Python VM is running and everything is installed, it will basically remove that loading pattern. So let's see if I can make it show if I refresh. There's loading, and there's the page. Let me go to slide 9 by pressing 9, a couple arrows, and this gets me back to this example. So how does it work? Slowing the slides with PyScript. That's okay. So I said you go to Google Slides, you edit all the slides, you take the URL, you call the converter to convert the PDF. It will download it automatically, then turn it into images, and these images are then rendered in PyScript. If you're interested in this, look up Fabio's talks. Fabio's done a couple talks, one at PyBay, one at, I think, PyCon.de. And there he used a different way of rendering slides. It was a very elegant way as well, but wasn't using LTK. So this is I thought I'd try an LTK version. But Fabio's version is using a combination of markup and HTML, which allows you a lot more freedom in animation and running things live inside the presentation as well. So those are all different ways. And he also runs it as a Python PyScript application from PyScript.com. Okay, I'm doing a time check. We got 9:06, I've got an hour left. So this is all giving you familiarity of like, why do we want PyScript? What are the benefits and what kind of examples can you run? Now, if you want to find out more about PyScript, you want to join the community and figure out like, yeah, where can I find more about the documentation? How can I talk to other people that are using PyScript? The standard page to go to is pyscript.net. This will get you a link to the examples. So I showed you some of them, like the WebGL one and the Folium one come from these examples. But also documentation will give you a lot of background about PyScript, how to use it, certain coding patterns. So I suggest you go there. If you want to talk to people and ask questions, go to the Discord channel. This is very active, managed by the PyScript team. They all work for Anaconda, who has been sponsoring PyScript for 2 years now, 2.5 years. And if you've seen the keynote this morning by Peter Wang, he mentioned that Anaconda has spent like $30 million over the history of Anaconda in all kinds of open source projects, and that includes PyScript. PyScript is an open source project. So Anaconda is also a sponsor of this event, of course. And I want to thank them for the continued sponsoring of this project because it enables me to write really cool applications. So let's see, what's next? So how do you write your code? So one thing is the first option. So like I said, PyScript is a static website. So you could basically build your PyScript applications in the same way that you do any web development. So VS Code is a popular one for that. If you install the Python extension and then live preview, you can actually see things that are happening. And we're going to use that for the rest of the tutorial. Option 2 is using another development environment. This is GitHub Codespaces, and it allows you to run almost the same as VS Code, but then in the browser. So this avoids you having to install VS Code. So if you want to try out VS Code and don't want to install it on your machine, or you just want to access it from a browser URL, check out Codespaces. This is a video recorded by Nicholas Tollerfie. He is a principal engineer on the PyScript team. And he recorded basically all the steps. So if you're interested in trying that out, this is a good one to try. He also shows how you can deploy your application very quickly on GitHub GitHub Pages, and we have GitHub Codespaces. So GitHub Pages are it's basically a web server that can render the content of your GitHub repo very quickly. I've given an example of that already. You may not have noticed, but it was running, like the LTK kitchen sink is running on GitHub Pages. So I still have it here. Yeah, so this one here, you can see, you cannot see the URL because it's not showing in the presentation, but it's pyscript.github.io/LTK. So that is the second way. The third way is go to pyscript.com. I gave you an example of the Christmas card. It's hosted there. All the examples for PyScript are hosted there. And this is a very simplistic IDE. So if you want to just focus on editing some files and see what happens, try it out, run it. This is a great way to start. If you create a new application on pyscript.com, you get basically the essence of what you need to do to host your application. So that's a good starter point for templating a new application. That's what I always do. I go to PyScript.com, I click on new and I get 3 files. And now I know what to actually put in my application. And I have a preference for VS Code, but maybe other people have a preference for just using, I don't know, Vim or Emacs. So Emacs has been around for quite a long time, and Vim as well. Sadly, Bram Molenaar, the inventor of Vim or the creator of Vim, has passed away last year. But the creator of Emacs for Unix is still here with us. And next week, there's going to be Emacs Conf. So if you're very interested in that, December 7 and 8. But with that, you can just edit your files from the command line and then serve them up on the server, your FTP, whatever. So if you're a command line person, that also works, right? So PyScript is not opinionated in how you have to write your code. Some people think that PyScript.com is the only way that you can write PyScript applications. That's not really true. It's a very easy way of running your PyScript application, but it runs basically any way you want. So I'm hosting this off GitHub.slides, and it's a little bit slower than normal. Yeah, this looks like quite a while to get this page. Anyway, enough talking, enough demos, enough examples. Let's actually build something. So what we're going to build is the following. So we're going to have a UI with basically 3 parts. The top left is a UI that we can interact with. There's going to be buttons, there's checkboxes. And that is written with reactive LTK that I already showed in the LTK kitchen sink. Below that, we're going to go to ChatGPT and basically give it the prompt, say like, I want to build a house, like how do I do that? And ChatGPT will give us some strategy for applying that goal. So in the prompt, I ask it to make it achievable or find out how I can break it up in small parts and whatever. So it gives a surprisingly good advice often on what to do. And on the right, I make a call to DALL-E and with the same quotes, with the same prompt, basically. And it will give us variable results. Let's put it that way. So sometimes this picture looks good. So this one is actually a very good one. But we'll see that mileage varies. OK, so the to-do app, I'm first going to show you the end result. And then we're going to look at how do we actually get there and what do we build. So this is the end result. If I go to my overview here, let's close down my virtual environment folder. So there's a folder called assets. There's a folder called source. And then there's an index.html. So again, the index.html is not so interesting in this case. Like unlike the Christmas card, we're actually doing a modular design here. So we separated out our files. So here we see the config is in todo.toml, and that is here. So here we define like the name of our app and the files that we want to get installed when the app gets installed into the Python VM in WebAssembly. So in this case, we need the to-do model, to-do view, OpenAI, and UI. And these files are then copied into the runtime system so that I can successfully call this Python script here. And all I do is import UI, and then the side effect of importing this module is that it will create the UI. So this is about 87 lines. The model is about 12 lines, and the view is about 30 lines. So this is like very small, right? This is like 130 lines of logic to build this UI here. So let's open model.py and see what we are going to have. So to-do model is an abstract, it's a subclass of local storage model. So this means that if we make any changes to the model, it will tell the UI to update, but it will also copy the changes to the local storage. So this means that if I make a new to-do item here, let's say learn PyScript LTK, and I make this my new to-do item. It's actually loading that suggestion right now, and it comes back from ChatGPT with an answer quite quickly. DALL-E takes a little longer. Makes sense. There's more things to generate, more pixels, and it will come up with a picture. So here's the picture to learn PyScript. So you can see PyScript LTK in here. I actually figured out that PyScript LTK is a Python library. So it has a Python logo, sort of. And it's for coders. So surprisingly, I was surprised that ChatGPT actually knows about PyScript. It knows about LTK. And if you look at this description here, it says things like, you can set alternative goals as learning a different Python-based GUI toolkit. So it knows LTK is a toolkit. So it has pretty good awareness of, what coders find important, even on PyScript. I was pleasantly surprised. So the view here is, as you can see, a checkbox, an input field, and a garbage bin. And that works like this. So we have an LTK checkbox, which is item completed. So I can do this, and now it's actually saved. So if I refresh this page, because the model changed, and the model is a local storage model, these changes are automatically saved in the local storage for this particular app. That's a choice that I made, right? I could have made a regular model and then listen to the change event and then save it in SQLite or save it on a server somewhere. That's a trade-off, but it makes it very easy to build local storage models this way. Now the UI is a checkbox, an input, and a label, and that's in a HBox, a horizontal box, as we saw in the LTK kitchen sink. There's vertical boxes, horizontal boxes. And a horizontal box means that they're on one row. So in CSS, HTML, CSS terms, this is a flex box that is laid out horizontally. So what does that look like? Here, like this and this and this. The styling is defined. If you can look at this, there's no styling here, right? This says just a checkbox, an input, and label. But if you're signing up, if you're representing a to-do model, in this case, a model field, LTK will automatically assign a class to this element. And these class names are predictable. So there are like LTK model, and then the name of your model, followed by the field. So the checkbox here is the completed one, and we can see the width is 50. So if I make that like 90, and then the height 33, like 87, you can see that it gets bigger. And what you saw too, I think you saw that, it actually made the changes while I was typing. So that's, so you can see I make it 8, and there's a 10. 10 is a little small, like 30, or maybe 40, of the 400, 33 maybe. Yeah, that looks a little bit better. And maybe not 90, maybe what is 80 or 70. So you can experiment very easily and see, what the result is of your changes. And when I make these changes and they get rerun, you have to understand what's happening here. It reloads the page. The page has that index HTML. There we go here. So it basically reloads this completely every time we type one character. It starts MicroPython. The MicroPython installs these files into the virtual file system in WebAssembly. And then it loads this script here, it runs it, and that imports UI, so it runs this, and then it runs that and that and that. So this whole thing, the whole process, starting up Python VM in PyScript takes about 40 milliseconds. And this is why it can keep up with me typing. So if I go back again to the to-do CSS, I'll show you again. I'll make some changes. And you can see that whenever I enter a character and remove it, it's just directly. It's almost like, it's too bad it's actually blinking. That's a little bit, and sometimes that's annoying when you're typing and it's constantly blinking. maybe got to figure out how to do that. So not reconstruct from the whole thing, but keep the last picture there and then just overdraw. But it's amazing how fast this is. So earlier I mentioned that a lot of people think that if you have to write a PyScript application, you have to host it on PyScript.com, but that's not true. Another misconception that people have is that PyScript is slow, and that's definitely not true. So if you use PyScript, MicroPython for PyScript, you can see it can start up like in 40 milliseconds. And I can show that again if you go back to the kitchen sink for PyScript, for LTK. So this is running MicroPython. So if I refresh, this brings up the MicroPython VM. Every time I click, it starts up the whole thing again. So here we can see it's around 93 milliseconds to start up the whole page. So the whole process of loading the page, running the Python code, installing all the things that I need for my Python application, running it, and then constructing the page, and that in its all is 92 milliseconds. I tried this out this afternoon when I wasn't sharing my screen in this tutorial environment. And when I did that this afternoon, it was like 40 milliseconds. So that shows like the fastest you can go. Now, how long does it take with PyData? A little bit longer, but not that much longer. So if I refresh this, you can see that the whole page takes about a second to load, to bring up PyData, which is a full CPython VM that can run things like pandas, NumPy, SciPy, basically anything. So if your application takes a little bit more than what you can do with MicroPython, you can still do it in PyData. But you have to, that's a trade-off there. So anyway, so that's a little sidestep in performance. And if you use MicroPython, and then you can do things like this, right? So it's really fast. Now, if I want to try this out, this performance with PyData, I can do that too. I go to my index.html. I'm just with one character difference. This is now loading PyData. So I go back to my to-do CSS, make changes again. So let's say 20. So now it takes a little longer. You can see it's actually not as fast in getting the feedback there. It's taking like a second to refresh, which is still okay. If my application is a little bit larger, then people won't mind like getting 1 second startup time for their web application, because it saves you all the time that you would normally do. Like, remember in the beginning, we talked about like package installation. Normally you would have to install Python, then you would have to install the packages. You have to run the package installer, or like pip install -r requirements, or so all of this is done now automatically. So it's like 0 install, click on the link, and we can run any Python application. So this is a really nice distribution model for data science applications that you want to write, or just information presentation, or things like the to-do app that we're going to build. Okay, so this is like what we're going to build, and now we're going to like start with something a little bit less evolved. So this is the to-do start, I call it. And I'm going to take a quick look at questions, or if anything has. This is the wrong one. This is the event feed. I want to see this one. Checks. So the slides are there. Is this what PyCafe does? So Fabio says PyCafe is slightly different, but yes, it uses PyData. So with PyScript, you can use multiple Python VMs. And like Fabio mentioned, you can even use other languages. So that's an interesting aspect as well. Can we generate some column graphs with LTK? Yes, we can. Show that. Can we use PyScript on an HTML hosted or in an S3 public bucket? This is a question from Sylvia. And Fabio says, yes, absolutely. You can share it just as a static website. So I mentioned that earlier. You can run this on GitHub pages. But another example here is PySheets. So let me bring that up. And this is called PySheets.app, but this is hosted by DigitalOcean. So it's running on a DigitalOcean machine. You basically FTP your files there, and it runs like any web application, including PyScript applications. My personal homepage is running on another web provider, which is PHP based, historical reasons. But it works really well for PyScript as well, because it's just a static file that I publish there. So PySheets, so somebody asked for graphs. So PySheets is, it's a PyScript application. So I'll create a new file here. So earlier we used something like Folium. So I'll import Folium here. I'll say I want to use Folium. And if I now refresh, you can see, yeah, it starts up really fast, right? So this is building a spreadsheet in the browser. I'll refresh again and again. So each time it brings up the UI very fast because you use MicroPython and it's rendering the whole UI there. And it's starting a worker in the background. So if you're asking, like, can I do both, right? Can I have a fast UI and do I have the flexibility of running pandas and matplotlib? Yes, you can. And you can create a worker that is like a web worker that can run Python code. And typically you would run that one on PyData, and that's where you send all your work to. So what does that look like? So I'll import a CSV file from somewhere. So I'll take the first one here. Let's see. That's not the one I wanted. Cancel. So I think it's this one. This is the airport codes. Yeah, that's the one I was interested in. So we see a preview of that. There is 81,000 rows. There's quite a few columns. There's a municipality, a GPS code. Okay, load that as a data frame. So what I did now is I say PySheets.load sheet, and it loads that URL. And what I get back is a data frame. So this was loaded in the worker. You can see the worker says here, it ran in the worker for cell A1. And the worker has still access to the PyData data frame because it runs in standard CPython and it has added the package for pandas. But my UI is in MicroPython and it only renders the HTML preview of that. So like you would do in a Jupyter notebook, you would render that in a cell as a preview. You would not render 81,000 rows, of course, because that wouldn't scale. But here we can see this is a preview. So what PySheets does, it will let you, maybe I should switch to demo here, because I've been talking and showing things and people didn't see it. So quickly, so here we did, I'll restart again. I will restart again. So I think this is the point where you missed me, you lost me. So what I have is I clicked on import, I selected the URL that I wanted to download. So the CSV is downloaded. Here we have 81,000 rows. And I can look at the data frame. I can like scroll to the right to see what columns there are, and one of them is coordinates. Now what I want to do is render this as a map. So I already imported Folium earlier. So yeah, my worker, which is here at the bottom, which started up a little bit slower than the UI, of course, because it has to do more. It has to import pandas, matplotlib, and all of that. So that takes like 3.8 seconds in this case. If I redo it again, you can see the UI comes up very fast, but the worker is like 3.8 seconds. And again, this is because I'm doing video. I'm sharing my screen and using a lot of my bandwidth. This is normally 2.8 seconds for this worker. Now I have this data frame here, and I want to render this as a Folium map. So I can write the Python code for that. I can say like, let's write that in cell E1. And here I can start writing the Python code to render this as a Folium map, but I don't know how to do that, right? I'm pretty good at Python, but I don't really know how to visualize that. So what I can do is I can write a prompt, and I can take that prompt and type it in here. So here's a prompt that I prepared. So it says, visualize the existing data frame in A1 using Folium. Use the elevation feet. So that's this one here. It shows the number of feet. And then select the airports that are higher than 14,000 feet and parse the comma-separated column called coordinates to get the lat long. So this is all I can say, right? This is in human language, I can say this. And then I say generate code, and this now produces the code to run to produce this picture here. So here we can see it actually has a picture. So the map, and it kind of shows it, but it's like, maybe the zoom is not right, because here it says zoom start 2. So I changed my prompt and I say change the zoom to 1. And then regenerate the code. So it creates new Python code. I send that Python code to the worker. Worker runs again. It produces new results, as you would do in a Jupyter Notebook cell. And that output result, which is HTML, is then rendered in this particular previewer here. So now we can see the actual elements. Now this is with a map, which makes a lot of sense. But we can also show graphs. So let me use another example, like the Forbes AI 150. So this particular one is a data frame that comes out of this sheet. And the data frame says, here, click here. It says, get the sheet in this range, and that gives me a data frame. So this is the preview here. But I can also say, like, render this as a graph. So here, this is the code I actually had PySheets. The prompt I had PySheets generate by clicking on the G1 button. And then it generated this Python code here. So it says group by, size, and then plot kindness bar. So this is vertical bar. I can also do bar H and then run the script again. And now it's a horizontal bar. But maybe I can say something in the prompt as a pie chart, and then have ChatGPT generate new code for me. And now all of a sudden I have a pie chart. And I didn't know how to do that, right? I could have typed in pi here instead of bar H, but maybe I didn't know, like, this. I wouldn't have figured out, like, to call group by. So this really accelerates figuring out how to draw things like bar charts. Is this done in LTK? No, it's not really. It's running in a worker, and the worker generates the HTML that gets then sent to the UI, and the UI renders that using LTK. So this is actually a dialog that is created using LTK. And it's also resizable, which I said it. So if you're interested in what this is, like PySheets, you can go to help, about. And if you want to look at the source, the whole source for this particular PyScript application, so this is a open source PyScript app, you can browse it around and you can look. This is on GitHub. The entire source is here in this folder. It's highly documented. There's unit tests for it as well. So yeah, explore it, see what you can build. So let me go back to the to-do start. I hope I didn't lose you too long. I got too many windows to keep track of. That's the problem with if you want to do multiple demos at the same time. So what I had was a to-do app. Now it says, rather than have a to-do app, it says, let's build a to-do app with PyScript LTK. So this is the code I'm going to remove. I'm using VS Code Vim bindings because I'm a Vim happy user. So behind the scenes, I'm actually deleting lines by typing DD. So go back to the model. We said, like, we have a subclass of local storage model, and I commented out these 3 lines. So let's uncomment them. So we have something to actually represent. So a to-do element, in my case, will have a note, whether it's completed or not, and then the suggestion from ChatGPT, which I store in it. The view says, like, let's take that model So here you can see it gets passed in as an item here. And the yellow underline means that it's unused because I commented out this code, of course. So let me uncomment it in the box here. And there's a callback. So I said like it's all model view controller based. So it's declarative UIs with reactive models. So you don't have to worry about events. But in this case, if we want to delete a node, this is not something we can easily do with model view controller, right? This is really an active thing that we have to do. So that is a special case. So removing things has an event handler. So you can see here, if somebody clicks on this garbage bin, then we're going to remove. So remove here is then invoked. We get past an event, but we don't care about the event. We're just going to say remove myself. So when this view is actually rendering the to-do item, it can delete itself. Now, when it deletes itself, it also, I tell the to-do item to remove itself as well, so that it's removed from persistent storage. And then finally, this is how we can create multiple items when we start. So this is actually make it easier for us to create new things or load new things. But also when we press a button and says like create a new to-do item, this function is also invoked. So let me save this file and get rid of the PyLint errors. And then finally my UI, when it loads. So this is the code I commented out. So let me uncomment it. So here we see like we have a button here. That's the new button. When it's invoked, we call create to do. So create to do is a little bit up here. That will go to the view to create a view with a new model. So this is an empty to do item. And then it will update the summary. So let's click on new and see what happens. So when I click on the button new, it creates a new item here. And it updated the summary. So update the summary says, it basically calculates how many to-do items we have, and then it sets the summary to a new string. So for that, we use a reactive LTK model. And yeah, what we see here, it also populates in a vertical split pane. So the way that works is, like you see the hover here when I move over this element, and then it also realigns, resizes the elements there. This is also a vertical split pane between a vertical box and a pre-formatted attribute. So if I go here and I go there. So pre-formatted means it uses teletype font. If I make this a text area, oops. So text area, then close. Yep. Then it looks like a text area box instead of a teletype. Well, it's still teletype. If I make it a text, then it will be standard font. You can see. So there are different ways of like rendering this information either as a read-only text or as a editable text, or in this case as a pre-formatted text. So this is the pre-tag in HTML, basically. Somehow code completion here thinks that I should call it pre-formatted text, but that's really not it. I'll undo that edit. But okay, so that's this one is green. So earlier I mentioned you can edit the CSS to change things, and if we add things, I say like for model elements, there's a class automatically added with a predictable name. But I can also override that. I can set my own class. So I say like this V box, which is this box here, with all the to-dos in it. I add another CSS class to it and call it to-dos. So now I can go to my to-do.css and I can look up to-dos. So that's this one here. And here I can see the background color is this. The border is solid. There's some heights things. So if I move over here, we can see the actual color setting there. So let's make that orange. So I can play with the color very quickly. You can see it's updating, yeah, as soon as I pick a different color. So let's pick that one. I like that. So this is a combination of declarative UIs that are constructed using reactive views, but the styling is done using CSS. And this is a traditional way of building, you know, styled applications in web applications, if you use JavaScript, for instance. Now we can also override specific fields. So if I want to make, let's see, go back to the UI here, and we see the to-do tasks. I can also say, like, I added a class for to-dos, but I can override certain things from the CSS. So I can say .css, and then say background, and I can make that, well, it suggested something for me, but let's make that red. And now you can see I can like inherit the class in the CSS, but then I can override specific attributes and set it directly on the widget. So all other VBoxes that use the add class to do still get that other color, but specific elements can make, yeah, can change if I want to do that. So that allows you to combine both application level styling with themes, or in this case with style sheets, with specific style elements that you set on an element. Now, how do we call ChatGPT? That's also an interesting one. So if I see the UI here and I create a new item, it actually says create to do. It says update summary. It says view create, and then it runs the AI. So here we see run AI that is called. It looks at the parent, it finds that box, and then it says get suggestion for this target. So get suggestion basically, yeah, gets the information out. It gets the node from the target. So this node, what I have here, which is currently empty. And then it makes a call to OpenAI to get a suggestion. So how does that work? I can follow this link here. This one says get suggestion and image. We can see it says LTK post has too many positional elements. That is because I have installed LTK globally on my machine, and that's not really smart, right? We should use virtual environments for Python applications. And you can see this is a brand new project. I have, yeah, nothing here yet. So let me set up the environment first. So let me say environment, wrong one, Control P, environment. So create a Python environment. I say with VM, I use this Python VM, and then install the requirements from that file. And it's creating my environment right now. And then once it's installed it, we should get a better LTK here. So pip is there. Should install LTK as well. It's creating the environment. There it is. And now the error has gone away because I have, yeah, a more recent version of LTK installed in my own virtual environment. So now if I go to, yeah, like LTK proxy, it will go to the definition of that. Oops, control click. You can see it goes to that definition of that file. So this works the same way that you do normal applications, Python applications. So a lot of the standard Python tools will work automatically for this application, like code completion, even if you use like things like Cody. So I use SourceGraph Cody, which uses Claude for code completion. This all works on this Python code. And it's even able to figure out from looking at the context of my PyScript code what JavaScript suggestions to make. So it's predicting JavaScript APIs based on the context that it's seeing here. So it's a very helpful combination there. Okay, so what does it do? It says load from cache because OpenAI is expensive. I don't want to get the same thing twice. If it's in the cache, then I just show it. And otherwise, I go to OpenAI. So let's make a new to-do item. So I say PyScript or learn to play golf. I want to learn that. So I hit enter, it changes the file, goes to the model. It also runs the AI. And it comes back with an answer very quickly. So to learn golf, you have to start setting realistic expectations. And then you could also learn a particular aspect of golf. So let's make this picture bigger. This is actually a nice one, right? I'm not sure if you would hit the ball like this, and then you would probably hit these other people. But yeah, let's try something else, like learn to write pandas. I don't know if it can actually figure out what to do with pandas. Let's see, pandas library. So it figured out that I'm a software engineer, maybe based on my previous questions. And because the prompt I give is not specific to being a programmer, I could learn something about data visualization and manipulation. And here comes PyData or pandas. Yeah, pandas, it says there. So let me make this one a little bit bigger. So pandas, it actually got good. In master pandas, it's lean and measurable. So yeah, that's the limitations of DALL-E. You get like variable results, but here's a panda on the book. That's nice. So with that, you can see how easy it is to write a Python application in the browser. You start with your index.html. So we had that here. In that, you load PyScript. So you have to get it from somewhere. You can see the versions I'm using for this particular example are quite old, 23. I should upgrade. So let's hope that nobody in Anaconda saw that. If you look at PySheets and you go through the index.html, you will see that it's actually from 24.11.3 or something. So it's basically the latest version on that. So you create an index.html, you download the PyScript runtime, and then you download the JavaScript libraries that you want to use. And in this case, because I use LTK, I need jQuery, jQuery UI, and I need jQuery CSS. But that's because I use LTK. If you don't use LTK and you use like plain web apps, and you can use PyScript, PyScript.web for accessing the same elements that I showed you, like get access to the DOM elements from Python to the JavaScript space, basically. But it's going to be at a much lower level, so you don't get the nice abstractions that you have with LTK. So that's a trade-off. If you just want to do simple web app, or sort of like simple stuff in the web, you can also use PyScript.web. But in this case, I use LTK and I need jQuery. I import the to-do SSS, and then basically I run my app. I choose the Python VM I want to use. And earlier I mentioned you can do both. So you can have two Python VMs running at the same time. So I could have another one here and insert it in here. And then say, this is really a worker. So I make this a worker and I make this a Python. And then I do something else here, right? So rather than import UI, I would do something that the worker does, like import pandas, download the data frame, and do something with it. So this is how easy it is to have two VMs in your application as well. We're not using that in this particular example, but this is how you would do that declaratively from the HTML. There's also an API from PyScript that lets you create a worker on demand. So you can have 1, 2, 3, 4, 5, depending on when you need them. And that's what PySheets does. So PySheets starts up as a MicroPython VM. It builds the whole UI, and then it creates a worker on demand. So if you're interested in that, go to the PySheets repository and search for the word worker, and you very quickly find the space where it happens, the spot where it happens. Okay, I see we have 10 minutes left, so I'm going back to my slides, if I can find them. I think here they are. So what we built, a summary, is a PyScript application. So this one has a UI with some checkboxes and buttons. It uses reactive LTK. You don't have to do that. You can build your UI just in HTML and then attach your event handlers to it. It's all like what you find yourself comfortable with. We make a call to a third-party service, and in this case, ChatGPT and DALL-E. And when the result comes back, we render that in our application. So this is like how quickly it is. This is 120, 130 lines of code for the UI. The OpenAI is a little bit more complex because we have to deal with handling the key for ChatGPT as well. And I didn't want to give you my key, so you have to save your own key. If you got that dialog, it's all safe. It doesn't go anywhere, your key. It just stays in local storage. So what we did, we talked about why would you do PyScript? What is the benefits? How do you develop your Python application in PyScript? So there's multiple ways. You can use VS Code. You can use PyScript.com. You can use Emacs, Vim. You can use online IDEs like GitHub Codespaces. And then you write your app. You can try it out very quickly, make a change. You can see the differences rendered very quickly if you use MicroPython. And we have 8 minutes left. I was going to go in a deep dive and show you what the script tag looks like, what a toml config looks like, how you can call JavaScript, what workers are. But we all did that already. So let's look at the last part, which is performance. So PySheets here. So this app is interesting because it's quite complex, right? So if I refresh, this comes up and reloads, and then something in the background happens. So web apps, the performance of web apps comes down to network. So if I go to inspect in any browser application, you can inspect what is happening in the background. So in this case, there are messages printed here. We can see the structure of our application. So here we can see what all the classes are set and the different LTK elements, for instance. So this is helpful if you want to change your CSS styling. You can see the files that are downloaded, but this is the important one, is network. So network shows us like how long it takes to download our application. So let's reload this. And you can see all the different files that are installed and downloaded by the two Python VMs that I have. So one is MicroPython, that's the first one. And then the second one is in the worker. So here we can see the individual files that are part of my index.html. These are files from MicroPython and PyScript. These are Python files that PySheets uses to just run itself. So it's a very modularized application. So it uses something like preview and inventory, models and selection and whatever. So these are modules that have classes in them with functions that basically generate this whole UI. And then the worker is a CPython VM. So it downloads the standard lib. It runs Pyodite and Matplotlib. And you can see that it installs quite a few packages to be able to run the code that produces these pictures. Now you can look at how long it takes to load this. You can see if they're coming from the cache or not. So if I, for instance, disable caching, this simulates a really slow load because now it has to start from scratch. So it took a little longer. It took like a second to start. Let me try this again, if I can make this smaller. Reload. Because I wanted to see how long the worker takes. So this is like 4 seconds, 5 seconds, 6 seconds. So it takes like twice as long. So now you can see what the cold start behavior is of your application and what the impact is on that. Now, aside from that, The Python code itself could also be slow, but that requires instrumentation of your code to figure out where the bottlenecks are. There are examples of that in PySheets as well. So if you're interested in that, look up like the timeline, and it has a profiler built in that runs if you're having PyData enabled. Okay, back to that. So the deep dive, we showed you these particular elements. So PyScript application runs a Python VM that runs on WebAssembly. It is compiled for WebAssembly. It's a special build of the CPython VM that's managed by the PyData project. You also have MicroPython, which is a smaller VM, still is compiled to WebAssembly, but your Python code is unchanged and the files get downloaded and run in normal way. They have access to all JavaScript APIs, and the JavaScript APIs do all the magic for making changes to your web application, like changing DOM elements, registering event handlers. And then you can have abstractions on top of that written in Python that will make things easier to manage. Okay, we're nearing the end. So the summary, we're all done. Yee. We got 3 minutes left. I should have saved more time, but I think all the questions have been answered by Fabio. Let me see. I'm looking at this. So Seth says this is a neat use of MicroPython. Fabio agrees. We still see VS Code, no PySheet. Yeah, sorry for that. I had too many balls in the air. If we're talking about the code running on PySheet cells, I think you can store it somewhere and only use it to actually run that code block without showing. But I assume it's something that's not implemented yet. So in Jupyter Notebooks, you have caching for the cells. So if a cell runs, it caches the information, and PySheets does the same thing. So you could save the information. It actually gets stored in IndexedDB in the browser. So it doesn't go to a server. It stays all local. So that's an interesting thing as well. And I think we're running to 2 minutes.
Yeah, no, we're a perfect time. Just actually, there are 2 more questions in the Q&A.
Oh, there's another one. I'm looking in the chat. Yeah.
Yeah, so I'll just call it out here. So it picks up
Okay,
on the
thanks for this in-depth session. Super interesting. I'm curious what applications the PyScript team anticipates people will use this for. So I think the main interest in PyScript is that it will allow you to run Python anywhere without any installation. So if you have a current application that you normally distribute to people and give them instructions, you say install Python, but only this version, and then install these packages, but specifically these versions, and they mess up and then the app doesn't run. This makes it a lot easier to distribute your application because it's just a link. So you link your app as a web app, you put it on the server, people click on it, and it installs automatically with the right versions of everything. So it makes like painless install of Python applications to run anywhere, specifically in the browser. So PySheets is a great example of like the end result. I think that's I'm biased because I've written PySheets, but I think it's the most insightful or elegant PyScript application because it uses all the features of PyScript, but it also shows what you really want to do with it. So it's a hosted application. I mean, it gets downloaded to your machine, but it doesn't store any data on the remote server. And rather, unlike Jupyter Notebooks, it doesn't have a kernel that is on a server, but it all runs in the browser, in the local space on your own machine. So that is quite intriguing if you have an application that you want to deploy to people and want to run a dashboard-like application, for instance. You have a lot of flexibility in how you're going to render it, where you get the information from, and then put it in the right format, all in a language that you're very comfortable with. It's Python. So that, I think, is my interpretation, the best use of PyScript. Next question from Alejandra is, would it be possible in how to share a PySheet results, but without giving access to the code to non-code colleagues? Everything is possible. Of course, that's a question specifically on PySheets. So let me make it clear that there's a couple layers here. So we have PyScript, which is the technology that allows you to run Python in the browser. There's LTK, which is a toolkit that is written to write UIs on top of PyScript. And then there is PySheets, which is a specific, very particular application, very opinionated application that runs on top of LTK. So there's a couple layers here. So the question is specifically on PySheets. Yes, you can. So in this case where I showed the examples, I show the code and I show the result. But this is a decision I made. It's very easy to hide the code and just show the result. So if just the only thing you want to do is render the result to non-coding people. You show them the spreadsheet and the pictures, and that's what they want to see. So then it looks like Power BI or any other dashboarding application. And the cool thing about PySheets is that the code runs in Python, but PySheets itself is also written in Python. And you can call out from your cells to the outside. So let me see if I can actually do that very quickly here. So I have PySheets here. So I say try. And I go to help about. So on here, you can say click learn. And there are a couple tutorials here for PySheets. So this is not PyScript. This is just for the PySheet application, what you can do with it. But the cool one is the chess tutorial. So I already paid to the demo gods, so it should work. And what this one does is, because it's special, it's actually importing a module called chess, and this comes from PyPy. And that allows me to basically create a chess board to get the pictures from the pieces. And then from my cell, which is like I1, so this is cell I1, I jump out and I say like, get me the cell for this in the spreadsheet. So now the cell is actually telling the spreadsheet to update itself. And also set event handler, so there's on, whatever, yeah, on mouse down, I select. So this allows me now to pick a piece and then put it there. And now it moved, and now the computer is making its move. It's calling random. Is it coming? Come on, go. Okay. Well, the demo gods help me have. So it's rendering. Oh yeah, there it is. So that took a long time. Wow. So now I move this one, and the fun thing here is that you can do self-reflection as a Python application on yourself. You can change the whole rendering. And that's a specific feature for PySheets, but you can imagine that you can do this in PyScript as well. So one of the things I've been building lately is an LTK visual builder. And it's all written in PyScript itself using LTK. And it's very interactive, where you have a palette of things, you drag it into a view, and you basically update the representation. And that is all like 140 lines. So you can write really elegant self-modifying applications in Python this way. Okay, some hints where the limits of PyScript are. So it runs on top of WebAssembly. And WebAssembly is basically a virtual environment. It's like an operating system. And it has a native bytecode format that you have to use to basically calculate things. But it also has limitations. So it has 32-bit addressable memory. So in essence, you have 4 gigabytes of main memory available. Now, all the examples I showed you here don't even reach that, but 4 gigabytes is not that much. So you wouldn't do big data problems in PyScript anyway, because you have to download all the data to the browser. That's the first step. So you have to upload. So I showed you that CSV file, the 81,000 lines. That is still doable, but that's not close to 4 gigabytes. If you have one with 2 million rows, whatever, you wouldn't run this in the browser. You wouldn't run this in PyScript. You wouldn't do this in JavaScript either, right? So this is that's a careful trade-off that you do. So I think PyScript, the limitations are, bottlenecks are network bandwidth. It's the Python code runs a tad bit slower than on a really fast machine. I mean, WebAssembly is pretty fast, but it's not shockingly fast that you can get on a node, whatever. There's also single threads, because the web has single threads and it's asynchronous, everything that you do. So and it borrows that from the JavaScript model. So if you want to do pandas in parallel with multiple threads and doing vectorized programming, that will not scale that well. So these are all like, limitations that are built into the hosting platform that PyScript runs on. It's nothing to do with the Python code or the Python VM that we run, but because of the environment facing these restrictions. The second thing is security. So you run in a very secure container. So that means that you run in a sandbox. And that means that nobody else can get to that sandbox, but it's also for you. You start every time with an empty sandbox, and you have to bring in all your tools. And when all the tools are there, you can actually build the sandcastle, but then you shut down your app and it's gone. And then you have to restart again. So these are all intentional limitations of the execution environment called WebAssembly. And I think this is a very elegant composition where we can actually run Python in this way. You can build really intriguing, amazing stuff with the benefits of Python. But there are limits, yes. So you should be aware of them. There's no multiple threads, single threads. You have to think about asynchronous rather than synchronous. But this is true for JavaScript as well. So people have built amazing things in JavaScript. They run Doom in it. So we could do this in PyScript as well. Yep. And I think that got to the end of the questions. We're also reaching midnight here. So with that, I would very much like to thank you for attending this tutorial live. I hope you could follow along. I gave you links in the start to the repository that you can clone. Try it out. Let us know. Go to pyscript.net. Explore the documentation. Go to the community. See us on Discord. Ask us questions. Meet us there. Discord is very active with people asking you questions. And thank you so much again. It was great meeting you, and see you soon.
Thank you very much, Chris. And thank you very much to everybody who made this a very enjoyable and very interactive session. And Fabio as well, who's answering questions there in the chat. It really sort of livened things up there quite a lot. I'm sure we can agree about that. And also,
I want to show the PyData ducky who has been helping me with the demos.
So, oh, fantastic.
This one I picked up in a real life PyData event in London, actually.
Oh, excellent. It can't beat a good co-pilot assistant.
Yeah.
So what I will do actually is I will just drop some things in the chat. We're not really stuck for time because this is the last one. But I will just put some notes in the chat in case you missed them from the start. That's the first one. And the that's the first two actually. And the last one is here.
Yeah, thank you, Fabio, for being on the chat. I know you can't speak up, but it was great having you in the background and supporting me.
Great stuff. We're going to call it a night, folks. Thank you all.
See you all
for
on
joining
PyScript.net and go to the Discord channel. We'll have a discussion there, chat with you. See ya.
Bye-bye. Bye-bye.
Bye-bye.